The reason why we're here is to create arguments. One thing I want to remind you about is when we create an argument, you're having to what? Like, what's involved in that? Huh? You have to think, right? When you are creating arguments, you are thinking. Oh, Traylon, you are here. Good morning, Traylon. Did you forget to do something when you came in? You don't have it? Is anybody else I didn't greet because I was talking to people? Good morning. See, I told you good morning. Dirty liar. Okay, it's a little extreme. That's usually the adjective I put in front of the word liar, but yeah, that's a little extreme. My bad. Good morning, Miracle. There you go. Okay, so when you have to think, you are engaging your brain. You're going to learn more. And when you listen to someone else's argument, their claim, and then their evidence, and you evaluate it, you're going to have to think more. So now I need that iPad up. So all of that thinking is going to increase your understanding when we'll have a final discussion. So the biggest dissenting opinion is 11. Can someone give us a reason why they said 11 zeros? Dissenting means to agree with. Like, so the majority decision is 7. Dissenting means that you disagree with it. So it's this is a very common word in the judicial system. So whenever there's a ruling in a case, you have the majority decision, 7, and then you have the dissenting opinion, which is a disagreement, and then the evidence why. So you did 3x to the 4th.
Is that a minus sign?
Yeah, that's not the best writing. Minus 5x plus 17x to the 7th. So for those who dissented, those who disagreed with 11 or 7, they said 11. Why? Go for it.
Because you don't add the x
Okay, so you're saying that it should be 7, not 11. Okay, Marshall.
I just went by what the smart kid said.
What did the smart kid say?
He said it's the highest exponent.
Okay, so y'all are giving evidence for why it should be 7.
Who said 11? He's asking why y'all said
Yeah.
11.
So,
Sorry.
yeah, I appreciate Lily Kate. So, Rakai, Miracle, Phoebe, why did we say 11?
4 plus 7.
So you added the 4 plus 7, so you're adding those exponents? Is that what you're saying there? Now, one thing I want to point out, we need to be careful about this, thank you. If you're adding the exponents, did you know that the sum of those exponents is not 11? What would the sum of those exponents be for someone who knows why it's not 11?
What's your name?
28. I said, when I look at these exponents, the sum of the exponents on the variable is not 11. And I'm not saying we should sum the exponents, but I am saying that the sum of the exponents would not be 11.
So it couldn't be 11?
It would be a 12.
It would be 12. Remember that x is understood to have a 1 on it, right? Now, don't do that. David, I need headphones up. Please be aware that we don't want to sum the exponents. There is a case where you will, but this is not where it is. When we have standard form is what some of us have referred to, and that standard form is when we're just summing individual terms, you go with the highest exponent. What is that highest exponent called? So it's just called the degree. That term degree means the highest exponent. Does that make sense? When in standard form. So how many zeros are we supposed to have? 7. There we go. Here, there's a lot of debate about how many zeros we would have. Some of us said we have 0 zeros. Now, this is actually what the majority of today's lesson is on. Okay? So I just want to hear some reasonings about why we put the answers. We'll get to the correct answer by the end of class today. So what did you put and why? Go for it.
I put 1 because I think the x is understood 0. So that's why I thought.
So when we look at this x right here, it's an understood 1. So you're thinking there'll be 1, 0 because the highest exponent is 1. Okay? Anyone have another opinion to add on to? Guys, we have lots of answers. Am I asking for the correct answer? No, Mr. Kinney. What do I want? Just want to know why, right? So first answer is
Right.
1, 0, highest exponent. Just shorthand. That's a reason. Come on, I need another reason. There were lots of different claims. Thank you.
Did she say it can be 0 or it can be 3?
Say again.
Did you say it can be 0 or 3? I don't know.
Eliza said 1 because she said the highest exponent is 1.
So it could just. I was thinking like, you're saying something like that. Some of the where at least they added the ones.
So maybe 3 zeros. Sorry, that's supposed to be the second option. 3 zeros from sum of exponents. That's what you're thinking?
I'm not hearing that, but I think that's.
Right, that's what someone could say. Okay. Come on, I'm about to start calling on people based on looking at these answers. A lot of us said 0 zeros. Where are we getting that from? Go for it.
I didn't say an exponent, so I just put 0.
Okay, so I didn't see an exponent, so I just put 0. Now, are there understood exponents here? So understood exponent of 1. Because if you have an x, it's understood to be an x to the first. This, if I were to have this would actually be an exponent of 0. This is going to sound bizarre, but if there's actually no variable there, this would be understood as x to the 0, because what is anything to the 0 power?
Yes, sir.
Do this for me. Pick up a calculator, type 5 to the 0 into that calculator.
You said about what?
5 to the 0, put it in the calculator. Got 1?
Mm-hmm.
Is that true? What is 3 to the 0? 1 again? What about 17 to the 0?
It's gonna be 1.
It's going to be 1 again. So what is x to the 0? It's 1, okay? Now, we can see that. We've checked it with those calculators to see this. Here's why. If I were to have x to the second, what does that mean? What are you doing with those two x's?
Oh,
Remember, an exponent means to multiply, right? What's x to the third? So multiplying 3 x's? So what are you saying that an exponent is?
Repeating multiplication.
Repeated multiplication. So if I have x to the first, what do I have? 1x, but we got to be repeatedly multiplying, right? Or we have to be multiplying? That's what an exponent is. So you know what we're multiplying by? In every single one of these, actually? 1 times 1x. 1 times 2x's. 1 times 3x's. So if I have x to the 0, what do I still start with? 1, and how many x's am I multiplying by? There's no x's. That's why x to the 0 is 1. This also explains why if you go further with it, x to the negative 1, if you have a negative exponent, you're not repeatedly multiplying, you're repeatedly dividing. You start at 1 and you divide by how many x's? X to the negative 2. I'm still starting at 1. Remember that negative exponent tells me to repeatedly divide by 2 x's. That's all it is, okay? Notice, when we talk about a repeated multiplication, repeated division, what number are we always starting with? A 1, okay? And so that's why I was saying here, if it's just a 3, it can be understood as x to the 0 with it, because that's the same as 3 times 1, which is 3, okay? So that's the only time it's a 0, Marshall. Make sense? Roundabout way to get there. So we had that, and so that's why we're thinking zeros. But we have two major thinkings about how many zeros there would be at this point. We're going to look at this the rest of today. All right. Before I forget, make sure you're logged in. I'm going to. I could just want to collect this. No, that's that. That's why some of y'all got it and others didn't. I'm going to redistribute a file. If you do not get this file because you weren't here yesterday, let me know. If you did not get it, make sure you're logged in because you should get the file that we ended class with yesterday. Trayana, you weren't here yesterday, were you? Okay, yeah, let me know
Mr.
that.
King,
Send, yeah, you should get the file now.
Mr. King,
Yes, ma'am?
you forgot to call me here for enrichment. You didn't put my name on paper.
Who do you have for enrichment?
Miss W. Cause I had asked,
That's my bad. Okay. There's a note to myself. All right, so we should all have that ready to go. Here's what I need us to do at this point. So we already talked about it a little bit. Why are we here? And what's an important part of that learning to make an argument? It's not just arguments for argument's sake. It's learning how to think. It's learning how to listen to other people's arguments as well to build a collective understanding. But guys, that means more of us got to engage in this class. We got to talk, right? I've heard a lot from Eliza today. I've heard a lot from Lily Kate. I've heard from Marshall. Who else have I heard from? David a little bit. Shania started to get in there. Jamarcus said some stuff. That's a good chunk, but there's a lot more of us that are not engaging in that discussion. Engage, talk, make sense out of these things. So we're here to learn how to learn. We're here to learn how to think. Now, I do want to pause and I do want to say this, especially for those of us who came in to finish their test yesterday. I appreciate this class. I don't think I've said that before. As a whole, we definitely engage more and are less rude than some of my other classes.
Y'all guys so bad. That's why I had said that.
I understand. Hey guys, I teach every day. I'm aware. So the focus I want to put is this. I don't say it enough. I do appreciate y'all. I do enjoy teaching y'all, and I do enjoy teaching. But let's engage more. The whole thing is that you can always be more. Chase after that. Fight for that. Choose. Make that choice to engage and be motivated. And when you start rolling with it, it makes it easier to stay engaged. It makes it easier to stay positive and get going more. I can't make you do it, but I promise you, the more that you engage, the more interesting it becomes, the more you're going to learn, the more you're going to grow, and the better this class goes. Okay? So, I do appreciate it. Today our focus is learning how to create and graph higher degree polynomials. So you remember yesterday we looked at this fundamental theorem of algebra. It's what we just applied. Please pay attention to that language. The name of this concept that the highest degree tells me the number of roots or number of zeros is called what? The concept that the highest degree tells me the number of zeros or the number of roots is called what? Fundamental theorem of algebra. Thank you, Preston, for getting involved, and Lily Kate, right? That is a key concept. That is the pinnacle, or not the pinnacle, it's the foundation of everything we're going to study with this unit. It will show up on your test. I cannot explain that enough. Cannot emphasize it enough. Everything I told you that was going to show up on the last test, showed up on the last test. You've got to know the fundamental theorem of algebra. It's literally fundamental to everything we study in algebra. Now, here are our learning goals. We need to pay attention to this. We are going to focus on dilating functions by non-constant values. What do I mean by a non-constant? It changes, so what changes in mathematics? Variables, right? So we're not dilating. So if I had y equals x plus 1 times x minus 3, that's what type of function? Quadratic, right? Let's say I dilate it by 3. That's a constant. Is that going to change the type of function it is? Or is it going to stay quadratic? That's going to stay quadratic, right? When you dilate or you translate by a constant, it's not going to change the type of function. But when we do it by variables, it's going to create what? Higher degree functions, specifically polynomials. And so we're going to look at how the linear factors creates zeros, and we're going to use those linear factors to figure out what the shape of that graph is going to look like, okay? And so we're going to be sketching graphs based on those things. So here's where we got to yesterday. Go ahead and have your book open to M1-141. That's what we're answering by the end of class today. Okay? So we're going to revisit that at the end, Eliza. We're going to see what we know based on what we learned. So M1-141.
You can put that.
Okay. So this is where we're picking up off of yesterday. Remember, we examined this function right here, f4 of x, and,
What page?
141, M1-141. Okay? So, we looked at f4 of x, and how did we calculate f4 of x? How do we figure out what f4 of x, that pink function is? There we go, right? f1 of x times f2. So one thing I want to point out about this is, what I could have done for f4, that's not what I want, f4 of x, is, what is the expression right now for f1 of x? By the way, f1 is based on a and b. So what is the expression for f1 of x? 1.6x plus 3, right? Slope-intercept form. That is the function, I could say that is the function that I'm starting with, and then I am multiplying by f2 of x. If we multiply, what is that also going to be called? We saw it in the objectives, it started with a D. Now we're dilating, right? f2 of x, is that a constant or non-constant expression? Non-constant, that's a variable, right? Not just a variable, specifically it's 1.6x minus 3.5, right? So I'm dilating by a variable. And so what we saw is, this was what type of function? Linear. What degree is that? First degree. Then we dilated by a, what type of function is this? Linear.
Linear.
And that was what degree? First degree. And when we dilated, let me actually back this out just a hair. Actually, that's what I should have done. Okay? So I changed the y-intercept just a little bit. And when we took a linear and we dilated it by a linear, we got what type of function? Quadratic. That's a key to understanding what's happening here. Now, how did these factors inform us of how this function was going to look? Well, that'd be 1.6x minus 1. What did we see as the connections between the factors, those linear factors, and the quadratic that we got as a result?
Roots.
The roots. What about the roots?
3, 0, and then -1, 0. Oh.
Do we see a 3, 0 and a -1, 0?
No, I think that's a positive 1, 0.
So first off, there is a positive 1 and a -3, but look, are those the roots that we have here?
They intersect.
Okay, say again.
They intersect.
They intersect where?
They exact.
Okay, so we do see they have the same roots. They have the same x-intercepts. But notice, it's not the -3 and it's not the 1. Anybody know why?
Those are y-intercepts.
Those would be the y-intercepts, right? What is 3 times -1? There's my y-intercept, -3, 0, -3. But come on guys, what do we know about zeros? Because we're very close to the zeros. Because I will point out, Naisha's on something, because it is x minus r1 and x minus r2, but what's the issue comparing this factored form to this factored form? What's different? That slope, that rate of change at the front. Notice Naisha how it has that 1.6 there? This does not, right? But how do we calculate zeros? Our equation needs to equal what? And so if we have that factored form set equal to 0, what key property did we learn last unit that we can apply here? That's that zero product property. Notice 1.6x plus 3 is equal to 0. So notice, Naisha, how I get that minus 3? But I'm not done yet. What do I still have to do?
About 1.6.
Okay, so divide by 1.6, or remember I can use that reciprocal. Hey guys, what is, you have calculators, negative 3 times 1 divided by 1.6. Remember, you can also hit the little calculator button to bring up, it's right in between escape and tab. It'll bring up your scratch pad so that you can look at the scratch pad and then go back to your file. Negative what?
1.8. You said negative 3 divided by 1 times 1.6?
Times 1 divided by 1.6. Remember, we're essentially dividing by 1.6. What again?
Negative 1.875.
Negative 1.875. Negative 1, does that look to be a little bit less than 2? Negative 2? Yeah. So, does that make sense, Naisha, why it's not the negative 3, but it's that negative 1.875?
Yeah.
So notice, guys, the x-intercepts of the factors, the zeros of the factors are the zeros of the what? What is this called? Parabola, the dilated function. That's key here, and we're about to get some interactive elements to this so that some of us can get up and start moving. The last thing, though, because I do want to point this out, is we now know the zeros. That's where one of the major things we left off yesterday. But why is the parabola positive? Why? Notice how that all those values are above above the x-axis. So all of those values are positive. Why is that?
Negative times negative is positive.
What's negative?
Wherever the 2 lines are down there.
So the 2 lines. Look at those 2 lines. Remember, this is f1 of x, right? f1 of x, is that whole expression my x or my y? That's y. So here are the y values of that factor, right? Here are the y values of the other factor. So if I look at these y values, what's a negative times a negative? So all of this is positive. But we know it's got to be coming towards this what? The x-intercept, that, what's the other word you used, David?
0.
0, right? X-intercepts, zeros, roots, whatever you want to say. But then we look after that 0, and now it's in the negatives. Why?
Positive times negative is negative.
That linear factor has what type of y values? Positive. Jayla, what type of values does this linear factor have? Negative, okay. And Hayden, what's a positive times a negative? Negative. Do you understand why we're saying this is positive and why these are negative? Okay. Notice these are all negative. So why in the world does it all of a sudden start to turn here? These are negative values. Why? And it stays positive times negative. So why does it start to turn at this vertex? So it starts to increase. Why does it start to increase though?
The parabola, that's how it works.
That is how a parabola works, but also remember, all of these numbers are negative, and what do we know it has to get back up to? It's got to get back up to a positive, but it's also got to get back up to the 0. And so it's got to start to increase. If it's in the negatives and it comes up to 0, or it has to come up to 0, right? So it's got to turn at the vertex and start to come back up. And then after that 0, look after that 0. What do we now have? Positive times a gives me positive. So my point is this. What is creating this second degree function? First off, what's creating this second degree function here, that parabola? Well, we see the 2 zeros, yes, but look at the equation. What created that second degree function? 2 linear factors, right? What can I use to help me sketch that quadratic function? Because I'll go ahead and tell you, if I were to put that into standard form, that quadratic function would be rough to look at. But I can still sketch it based on using the what? The linear factors, right? Can you graph 2 lines? I would hope so. And if you can graph 2 lines, can you then sketch out that parabola? Yes, Mr. King. Great job, guys. So let's do this really quickly. I want us to do 2 or 3 of these all together. So here is another, let's actually do this. Let's get rid of that. Let's use this graph right here. So notice we have 2 linear factors. First off, f4 of x. We know it's going to be the multiplying f1 and f2, right? That's how we're getting it? You good with that? So what is f1 of x based on the a and b values? Be careful, that's a 0.6. So 0.6 x plus 2, right? Slope and y-intercept times, so -1 x minus 1. So what we're trying to do is we're trying to graph that quadratic function, that second degree polynomial. So, can I get someone to come up here and just identify a couple of points? First off, what key points should we identify?
What I use?
What are you talking about? You give me a little bit more clear language with it. Or can someone add on to?
Maybe right with the 2 functions.
So the what?
What I intersect the x and y.
So where they intersect the x and y axis? Is that what you were thinking about, Shania? What were you thinking about?
What I bought the same point.
So you're talking about the point of intersection right here?
Yeah.
Okay. So, do we need x and y intercepts? Do we need that point of intersection? What are we thinking? And also y. Let's put on those thinking caps. Let's engage. Preston, Marshall, eyes up here, come on. Okay, let me ask you this. What key points did we look at last time to inform our quadratic function? The zeros, right? Did we look at any other points than the zeros? We did look at the y-intercept, and we could look at that here. So let's look at that in a second. But what was the focus? The zeros. Can someone identify, I just need you to identify 2 points. What are the zeros then of my second degree polynomial? Come on, let's draw it up here, Tevin.
Is it the 0?
Let's find out. We'll mark where you think they are, and then we'll discuss. Jose, you with us? Okay, come on. All right, does anybody want to push back on or ask a question about those being the zeros? Naisha.
Where did you get that from?
They're not the 0? I thought it was
So you're not sure where he got that from? So can you explain that a little bit more, Tevin, or can anyone else add on to? David, you got it?
Oh, no, sir.
Oh, you're gonna push back
Are we
on?
supposed to set both of them to 0?
So we could. What are you talking about? Setting the two what?
Thank you.
The two factors equal to 0?
Yeah.
Okay, let's try that. Right? So if we want zeros, what do we know the y value is?
0.
0. Now I can use what key property?
0 product.
There we go. So 0.6x plus 2 equals 0. And -1x minus 1 is equal to 0. What do I do at this point?
Subtract 0.
Okay. 0.6x equals -2.
Then, divide by 0 plus 2.
Okay. So 0.6 or -2 divided by 0.6, or you can use that reciprocal. What is x? I got a lot of students in this classroom who have not picked up a calculator to engage in this, which means we're not engaging in general. Come on, pick up calculator. What do we get?
I got 3.3. I don't think they're right there.
Positive or negative?
Positive.
That's a -2, you know that, right?
I'm tripping.
So -3.3 sounds about right to me. So Naisha, -1, -2, -3, -3.3. So do you agree with Tevin now?
Yeah.
So Tevin, how did you know that without even showing all that work? What is wrong with you?
I know I was right. But
What did you use to inform your
I
decision?
thought the zeros on the intercept was like, I thought it was 0 then the x-intercept.
So notice like these are those linear factors, right? Like that blue line is f1 of x, correct?
Yeah.
And the 0 of this linear factor will also be a 0 of the parabola, the quadratic, the second degree polynomial. Okay, so there's a 0. All right, good with that? So now let's look here and let's check it. Plus 1, negative x is equal to 1. X is equal to negative 1. Is that the 0 that we see right here?
Yeah.
Sir.
That is, okay? So now we have the zeros. Who wants to come start sketching the part of the parabola that would be to the left of this 0? Doesn't have to be perfect. I just need someone to try to sketch what it would look like to the left of that 0. I need someone to make a claim so that we can build off of it and discuss and understand.
Grab the sketch, I can't just say it.
Gotta come up here and sketch. Come on, Ethan. Come on. Stand up. You already messed up. You told me you have an idea. Okay. So you're saying it's coming all the way through here. Okay, so we basically have half of this parabola. Does anyone want to sketch the next piece? Try it out. Come on, Aisha. And tell us in a second why you're putting the values that you are, or why you sketched it that way. Okay? And so we would want these to connect, right?
Yeah.
Okay? Pretty vertical in there, but let's check it out.
Alright.
Nope, that's not what I want. So I'm going to go back to graph entries, line edit. I'm actually going to add F4 back in. So what do you think? Perfect, no, but pretty close?
Alright. Yeah, somewhere.
Somewhat. I mean, there's that pink, comes up to here, goes back down.
I just messed it up.
It's okay. I mean, here's the thing, and this is what we need to focus on. Ethan, how did you know that these values were going to be negative?
That's probably not negative, maybe.
We have positive values up here times negative values down here. Please notice, Ethan and Aisha and Tevin are not coming back up for the next one we do, so y'all need to pay attention to this. Positives times negatives gives me negatives. So Rakai, why did these start to become positive?
I don't know.
Well, if these are negatives because there's a positive times a negative, why are these positives? Could be that, but look at the linear factors.
Yeah, positive and positive.
Those are positives, right? They're above the x-axis. That's positive because it's above the x-axis. And what's a positive times a positive? Positive. Okay. And so, Jose, why are these now negative? Jose, why are these now negative? We talked through 2 of these now. You telling me you haven't been paying attention to this conversation at all?
They below the x-axis.
That's just looking at the parabola, but how do we know based on these linear factors? Remember, the red and blue line are these factors right here. So why would these become negative? Why would the pink become negative based on these linear factors? Tevin, I heard you start to say it. Jose, I'm coming back to you with the next problem we do. Why are they negative?
It's a positive and a negative.
Are those values positive?
Yes.
Yes, Mr. Kenny. Good job, Jose. And these values are what?
Negative.
And what's a positive times a negative? That's it. So we have our linear factors that are telling us what the shape of this graph would look like. A positive times a negative is a negative. We're doing one more of these before we take our notes in the book. Y'all need to start engaging in this conversation if you are not already. Okay. That defeated the whole purpose. All right. So let's look at this one. What's the first key points that we need to graph in order to figure out what our quadratic would look like? The two zeros. Okay, so I need someone other than Tevin to come up here and identify what the zeros of this quadratic is going to be. Come on, Sanai. Look, Kate, you focused? Sure about that? Okay. Yes, please erase that. Yep. Marshall, you awake and with us? Come on. Tyson, make sure you're involved in this thinking, okay?
You had it right the first time.
I will say this one thing to clarify, it doesn't have to be on the grid. Okay, anybody want to add on to, push back on, or ask a question about those zeros?
She's a little off.
A little off? Which one's a little off?
It just moved it.
That one right there? Where should it be?
On the line.
On the line, so a little bit to the left?
I think she missed it by a little bit. She knew what she was doing.
So now, does that make sense now? Okay. Please notice, like, it didn't, what I was saying is the zero doesn't have to be on the grid. It actually wasn't last time. The zero of the factor of the line will be a zero of the parabola, of the higher degree polynomial, right? The zeros of the factors are the zeros of the higher degree polynomial. Okay, so what I always like to do to now make sense of it is I actually like to draw a little vertical line. Notice, what's that vertical line going through? Not the vertex. This isn't an axis of symmetry. It's going through the zero. And I do that because it allows me to see where the parabola is changing from positives to negatives. So now, I need someone who has not been up here yet to show me what we would see to the left over here. And Jose, you have to do at least one of these three, so make sure you're paying attention and thinking through this. If you want to go ahead and knock this one out, you can. You want to try this one? Okay, so you need to do 2 or 3. Come on, I need someone to start the sketch. What would it look like to the left of that dashed line? Somebody volunteer that hasn't been up here yet. Just make a prediction. It's only by making claims and providing evidence that we can grow and learn. About to call on somebody. 3, 2, 1. Phoebe. Come on up. You're the lucky winner. Just make a prediction. Weirdly enough, I've never gotten upset with someone being wrong. And nobody in the class made fun of Sanaya a second ago when she got it wrong. We just helped correct it, made sense out of it, right? Huh? Who made fun of you? Oh, I do believe Naisha ripped you a little bit, but it's okay. Naisha is a little vicious. Okay, so, anybody want to push back on that part of the curve? Preston says he's good with it. Preston, why do you agree that the parabola would be up here, coming towards that zero? Okay. What do you think about evidence for that claim then? Come on, evidence, if we don't want to push back. Evidence for or evidence against that?
She's right on.
She's right on. Why is that, Ethan? So these blue values are positive, these red are positive, and a positive times a positive is positive. Okay, so we looked at the linear factors to the left there. So Jose, do you want to do it now for the part in the middle, or do you want to do the end? You going to do the last one? Jose, you're coming up once. I'm tired of you trying to hide. We got to do it at least once. Okay? Next piece. There we go. Okay, so you went ahead and did the whole thing. I'm good with that. So let's look at it. What do y'all think? Pretty good? Makes sense, like if it's starting to come down, starts to curve back up and go through here. Notice you had to go through the zero. Let's check to see if this is close to right. There is one detail that I will point out in a second that we could have done a little bit more efficiently. What you think? Pretty close?
Show.
Go down a little bit more. So what I will point out here is, Jose, you assumed it had to go through this y-intercept right here. But notice that's a -1, isn't it? And note how we're multiplying these things? What's this y-intercept?
That's 2.
What's 2 times -1? That's right here. That's why it comes down to here, right? So it comes all the way down, and then it starts to curve back up. But was his general shape correct? Yes. Would he need to provide me evidence on an assessment why that's the correct shape? Yes. All right. Let's look at the book. First off, what are your questions before we go to the book to take some notes that we can build off of later? Going once. Going twice. All right. Actively taking notes. You cannot grow and learn and study, which I know we're all going to be studying for this test because we got to be ready. Whoops. The plan is either next Friday or the following Monday. I will tell you this unit is an easier unit than the last one because we are not focused on solving as much as we are focused on graphing off of these ideas. So here we go. Notice we have here g of x in number 2. Well, actually, let's do this. The graph shows the function f of x equals x plus 3. Boom, there it is. We are now dilating by multiplying by the x value. So notice here is f of x, and we're multiplying by what? X. We're multiplying by the x value, right? So, by the way, it's in your textbook, number 2. G of x is equal to x times f of x. And it asks us right here how to write the equation to represent the new function. So how could I rewrite this for what the function g of x is? Notice they told us what f of x was a second ago. How would I write this equation? Okay, so starting with an x still. What's next? Anybody want to push back on or ask a question about?
I'm not saying.
Where's that coming from then?
The first.
The first function is what?
F of x equals x plus 2.
Oh yeah, if f of x equals x plus 3, what can I substitute in for f of x? X plus 3.
X plus 3.
There's g of x. Now we already know from what we've studied before, what type of function is that going to be? Multiplying those two would give me a quadratic. It's a linear times a linear, right? Yeah. Notice we would, if I were to sketch y equals x, this is the function right here. Has a slope of 1, a y-intercept of 0. And so, how did the dilation change the degree of the new function? Well, remember it went from, what's this degree? First degree. So we took a first degree, we multiplied it by a first degree and got a what? So a first degree times first degree gave us a second degree. So apparently when we're multiplying, is it just whatever the highest exponent is? No. That's what we need to notice here. Number 3 says identify the zeros of g of x. How are these related to the two linear factors? What's a zero? By the way, when we sketched it, right? What's a negative times negative? Positive. Notice how I used this 0. So positives coming down to here. What's going to happen after that 0? Does anybody remember which group Haley was in? Right there, perfect. Okay. What's a positive times a negative? Negative, so we come down. But what's eventually going to have to happen? It's got to what? It's got to turn and go back up. Why does it have to go back up? Not just because that's what a parabola does. What's it trying to get back to? It's in the negatives, it's trying to get back to the positives, specifically at that 0, and then it's got to go into the positives, because a positive times a positive is a positive, okay? So what are the zeros of g of x? There's two ways you can identify it.
Which one is K?
Negative 3, 2, negative
I asked what are the zeros of g of x? One of them is what?
3. 0, negative
Close. Remember, x comes first, right?
3. Oh, yeah.
And also, I will say that's an x-intercept. The way we would say the 0 is it's x equals negative 3. So you say the 0 as x equals, the x-intercept would be negative 3, 0. What's the other 0? X equals 0? Anybody want to push back on or add on to either of those? Ask a question about? Okay. You know, it helps when we write down the answers for number 32.
Oh.
Okay? From there,
We don't want to put it in K.
there you go, thank you. How are those zeros related to the two linear factors? This is the key. You have to understand this. How are those zeros related to the two linear factors? Remember, we didn't have that parabola originally. So how do we know to get those zeros for the parabola? Those are the roots of what? So, well, they were the x-intercepts of what? The linear
Oh, factors.
factors, right? They were functions, but we're also using them as factors. Guys, I need you to notice and pay attention. Those zeros are the zeros of the what? Linear factors, or we could even just say factors. This is a huge and big idea. Those are the zeros of the factors. You have to know that because you're not going to be given the parabola, but you are going to be given the linear factors and you have to graph off of that. You are going to be given the linear factors and you have to be able to graph off of that. So here's number 4. This is what we actually have already done. Please notice this is on the next page. And on number 4, they've actually already graphed that parabola for you. Does that look like what we predicted it to look like? Yes. Notice you don't have to have exactly the same points, but you do need to have the same positives, you need to have the same negatives, you need to have the same zeros. So consider the interval from -8 to -3. So here's -8 to -3. Notice that's where the 0 is. Why does the product of the linear factors result in g of x being positive? Why is g of x positive there? Right? Boom. Is that why? Positive times a positive? I say, look at those linear factors. A positive times a positive is positive, but is that what we see right here? No, right? Both linear factors have negative what? Values. Great job, right? Negative values, and a negative times a negative is a what? Positive. So we have our zeros, and we're using those factors to figure this stuff out. Hey, Miracle, do you not have a book?
No, I have one. I should take it.
You want to get a sheet of paper out to take notes so you can put it into your book later? There's free paper up here as well. Now, why is the function decreasing? Say again. Well, eventually, that's why it's going to be negative. So we're trying to get to the negatives, right? But there's another big idea. We have positives, and what key point are we trying to get to? That 0. Remember, that 0 is huge. And to go from a positive to 0, it's got to what? It's got to decrease. Okay? Decreasing to get to the 0. Decreasing to get to that 0.
Yeah.
Come on, I need more engagement, not just writing down answers. You gotta be thinking about these things too. I hear too often, Mr. Kinney, I don't know what's going on. The beginning and the foundations, were you engaged? Were you asking questions? Were you thinking about these things? If you're not doing that right now, the rest of the unit that builds off of these core concepts is gonna be rough. Now B says, consider the interval between -3 and 0. Notice, -3 is where the first 0 is. 0 is where the second 0 is. So we're looking right in between there now. Why is the product of the linear factors resulting in g of x being negative? So one of the factors has positive values, one of the factors has negative values. So one factor has positive values and one has negative values, and a positive times a negative is equal to a negative. That's it. We have negative values here because a positive times a negative is a negative. That's it. Don't make it more complicated than that. Do you have a question?
Can you use a different color?
Then the blue. Yes.
Can you repeat what you wrote?
One factor has positive values and one has negative values, and a positive times a negative is negative. And so remember, all the way through up to here, that function was what? What do we call it when it's going down? Decreasing. And it keeps decreasing, but all of a sudden, right here, what does it start to do? Increase. So why does the function change from decreasing to increasing? It's got to get back to that 0, right? It has negative values and it's got to get back up to 0. So decrease to increase to get back to 0. So what are the key points that are driving everything with this function? What key points do you have to look at?
0.
You got to look at those zeros. Those zeros are informing everything about how we graph this. And so hear me very clearly on this. You now actually have all of the information that is the foundations of everything for this entire unit. It's now just practicing and applying what you know in a slightly new context. These 2 pages cover everything you have to know. These are the foundations. These are the big ideas that inform everything else. Make sure you understand these concepts. Now it's just some practice here. With number 5, on the next page, it says the graph shows the function h of x equals a negative x plus 3. There it is. Choose several points on h of x and dilate by multiplying by the x value of that particular point. Instead of going that route, because that's going to make things harder than it has to be, let's just talk about this right here. Write the equation to represent the new function j of x is equal to x times h of x. Notice we're starting with h of x, and what are we doing to that h of x? Multiplying. But what is that transformation called? Dilation, right? So we are multiplying by x, which is also called dilating by x. When you multiply, the multiplication is the algebraic operation. What's happening to the graph is we dilate the graph. So they are very heavily connected.
Can you write the definition?
Of what?
Dilated.
It's not there.
Yeah.
It says on there somewhere.
It should be somewhere, but yeah, if you look at the very first page, in that very first paragraph, it says that you can dilate a function vertically by multiplying the function, right? So if you multiply a function, it creates a dilation.
Oh.
Okay.
What's it say where it says DEC?
It's on page.
Decrease to increase. That's under number 4. So the arrow is saying going from decreasing to increasing within that little part below the x-axis. Yeah. So dilating by x. That's literally what's happening. So we're dilating h of x by x. But the question says, write the equation. So j of x is equal to what? What's the real way we would write this function? Still got an x, right? Yeah. Times what? And I don't love this notation, so let's distribute it to make it closer to what we would actually usually do. So negative x minus 3, okay? So times negative x minus 3. That's what h of x is. We had what types of functions? What type of function was this? Linear. We dilated it by x, which is also linear. But when we did a linear times a linear, what did we get? Now quadratic. Now it's a second degree. We want to notice when we multiply 2 linears, we get a what? Quadratic.
Oh, okay.
When we multiply 2 linears, we get that quadratic. And so, notice we already have h of x here. What we want to do is we do want to graph j of x. And what are we multiplying h of x by? Just by x, right? How would I graph y equals x?
Put a 0.
Okay, so what key points do we know about y equals x?
Y equals 0.
So when I will say when x equals 0, y equals 0. Literally, y is equal to what? X.
Oh.
So when x is 0, y is 0. What about when x is 1? Hey guys, if x is 1, y would equal 1. Remember, I would point this out. My slope is 1, my y-intercept is 0. So I use a slope of 1. There's y equals x. We got to notice that. We got to graph that linear factor. From here, before we even sketch out j of x, we have the factors. What are the zeros of j of x going to be? We have our factors graphed. What are the zeros of j of x going to be? And? X equals 0. Trayana, we haven't done any work yet. How in the world did Ethan know that the zeros of j of x are going to be x equals negative 3 and x equals 0? No, not because he's smart. We've weirdly enough talked about this multiple times today. Because it was what? X equals negative 3 and x equals 0. The linear factors tell us what the zeros are, and they tell us where it's going to be positive and negative. How are these related to the linear factors? These are the what? The zeros, the x-intercepts of the what? Then probably yes, but how are they related to the linear factors? They are the zeros of what? of the linear factors.
Oh.
That don't make sense.
Why does it not make sense? Huh? Oh, we're answering the question. We're trying to get the parabola. We haven't sketched j of x yet. All we have, remember, j of x is equal to what? X times negative x minus 3, right? Or the negative parentheses x plus 3. This is just a cleaner way to look at it. But if those are my linear factors, or that's my factored form, how would I find zeros? I would set the function equal to 0. So think about it. And recognize, we already talked about this. I would use my zero product property, right? 0 would equal x. 0 would equal negative x minus 3. You solve that equation, x is going to equal negative 3. There's one linear factor. There's the other linear factor. So the zeros of those linear factors are the zeros of the quadratic. So I don't even have to go through all that work. I can just draw out my linear factors. If you can graph your linear factors, you know what the quadratic would look like. So I like to look to the left of my first 0. What's my quadratic going to look like to the left of that 0? It's going to be increasing and negative. These values are? These are, so positive times a negative? Negative. It doesn't have to be perfect. I just need it to be negative, and I need it to be increasing. Why is it increasing? Why is it going up? It's got to get to what? It's got to get to that 0. What's your question, Rakai? You got a question?
No, I just can't see.
Seriously? What, this is a red? Sorry, you said that earlier with the blue. I feel like that blue's a... Can you see that? I was going to say, why don't you come sit up here and make it easier to see? Okay. Is the blue hard for anybody else to see?
No.
Okay. Sorry, Rakai. We might have to get you to sit up closer.
She
older.
She old. Yeah, she's old.
She's old. Eyesight's going. So guys, a positive times a negative is a negative, and it's got to increase to get to 0. Now it's natural. What's a negative times a negative? Positive. So we went to 0. Now we need to go into the positives. But what am I going to eventually have to do?
Go back.
Go back down to
0.
0. Notice how I hit the 0 of that linear factor. After I hit that 0, what's going to happen? It's going to keep going down. And what's a positive times a negative? So it goes into the negatives. That's it.
That's all we want to do it too?
Not to justify it.
That's all.
We're going to go above quadratics, though.
How do you want us to explain?
What did we just say? How did we know how to graph it? What's the first key points we had to identify?
0.
Oh.
You had to look for those zeros, right?
Yeah.
How do we know that these are negatives? Because of the factors, right? A positive times a negative gives me, boom.
That's what you want us to say.
You know that justification is just explaining why, right? That's it. Tell me why. Okay. Almost done with this. Yeah, that's what I used to do. That's way more complicated. So used to, what I had students do is I actually had them identify the x's, identify the y's, and draw each of those individual points. You ain't got to do all that. Positive times negative, positive times positive, all that kind of stuff. Numbers 8 and 9. I'm going to do shorthand for this, but consider the interval from -10 to -3. Why is the product of linear factors resulting in j of x being negative? Why are all those values negative for j of x? We just said it.
Positive times b.
We have a positive times a negative. So shorthand, I'm just going to write out positive times negative is equal to a negative. Right? That's the big idea. That's what we just looked at. So you can get more detail in number 4, but that's exactly what's happening. A positive times a negative is a negative. Why is the function increasing?
To get that, to that 0.
Increasing to get to 0. That's it. So notice we're focusing on around those zeros. That's the big idea here. Now we're going to look between -3 and 0. Again, why are we using those x values? What's special about those x values?
You're off the zero.
They are the zeros, right? We got to look at those zeros, right, Jose? Got to look at those zeros. So why is the product of the linear factors resulting in j of x being positive? Why is j of x positive right here?
Oh,
Remember, the only way to make a positive is positive times positive, or, and we look right here, what do we have? A negative times a negative is equal to a positive. So why does it change from increasing to decreasing?
You got the zero?
It's got a what?
You got to the zero?
Got to get back to that 0. We got to get back to that 0. So, I want to point this out. Actually, don't worry about number 9. It's not going to help improve your understanding. It's not going to take away from it at all, but it's making things more complicated than it has to be. So, we're going to move to activity 2.2. We're also going to move to 3.1 in the calculator. So, move your calculator to 3.1. Preston, it's hard to move that calculator if you're asleep, my man. Yep. All right. Yes. Say it again. You got 18 minutes left. You can't hold it? We're supposed to be in class learning. Not if you were going into the restroom, you ain't? We gotta be in class to learn. It's that bad that you're gonna interrupt your education. It don't look like it's that bad. If it gets that bad, let me know. Haley, what's your question? Did you log in yet? Okay. So, here's what I need us to do. Please note, in this problem in the book, it starts us with which function? F of x equals what? Actually, look up here. This is where we're starting. We're starting off with f of x equals x minus 1. Now, in number 1, we're dilating f of x by what factor? Of x plus 3. So we're trying to write the equation for m of x. So, based on that information, how would I figure out what m of x is equal to?
X times x plus
Okay? Anybody want to add on to or push back on that?
It was a joke. Just gonna erase it. Just gonna erase it.
Okay? Why erase it?
It was a joke.
Okay? What is m of x then? Well, okay, let's do this. Do this for me. Start at the beginning. Dilate the function by what? What function? Okay, so I'm starting with f of x, and then what am I doing to f of x? So dilating or multiplying by? Okay. So what is m of x then?
X minus 1 times x plus 3.
Okay. In your calculator, what I want you to do is I want you to make f2 of x is ax plus b. So notice you already have the x minus 1 graphed. Now we need to graph the x plus 3. So what does a need to be? A needs to be 1. What does B need to be? 3. Thank you. So change your A to 1 and your B to 3. There we go.
Oh, we too much calculation.
Yeah, in the calculator. Nope, that's the wrong one.
That's so much.
I think A is already 1. B just needs to be changed to 3. Okay? So I would just identify a couple of key points off of that red function to be able to graph it into my notes. So what are a couple of key points from that red function that we should pay attention to? A needs to be 1, B needs to be 3.
There you go.
Yes, based on what's in the book. So guys, what key points should I graph in the book? The 0. What's our 0 then? -3. I want you to think about this linear factor right here. Why would it make sense that my 0 is -3? So look at the equation. Look at that algebraic expression. So remember, it needs to be the opposite, right? X minus R1. But also remember, especially if there's something in front here, we want to set that factor equal to, it's a 0, right? And subtract 3 from both sides.
Yeah.
So -3. So in your book, graph that 0 of -3. Do note, it's going by 2's. 2, 4, 6, 8, 10. So I need -2, I need a -3 right here. Please notice that's in the middle of the grid because, again, the grid is going by what units? 2's. Yes, Eliza. Say again. Remember, that's the factor that we started. That's the linear function that's already graphed for us. So yeah, that x minus 1 is right here. Okay, any other key points that you would know just looking at that factor right away? Or that we saw on the calculator?
Yeah.
What other one's 1? No. I'm talking about just the x plus 3.
Would be 3.
What's 3?
Second
3. The y-intercept would be 3, isn't it? So y-intercept of, so 2 and 3 would be right here in the middle. And you could use a straight edge, maybe the edge of the calculator or something, to graph that line there. I will also point out, what's the slope of this function? 1.
Yes.
Right, so I could do up 1 to the right 1, up 1 to the right 1 to get a few more points in there.
Up 1 to the right 1.
Down 1 to the left 1. Down 1 to the left 1. And so this is roughly the function that I would be looking at. Now I would draw my linear factors maybe in a pen or a pencil, but I would probably get out the box and I would do a colored pencil to identify what the m of x is. So let's make a prediction, not necessarily putting in our book yet because we want to make sure that we get this right, so we'll look at the calculator in a second. What key points do we think we would have of m of x? What are the key points for m of x? Huh?
Zeros.
The zeros. What would my zeros be?
-3 and +1.
-3, +1. Anybody want to push back on or ask a question about those zeros? We thinking that's right?
Why positive?
That's a great question. Anybody got an idea why +1? Someone besides Naisha, make sure we get more people engaged. Where's that +1 coming from?
It's automatic.
It's a sign.
So, you're thinking about that slope, but that's not telling me the 0.
Oh.
Notice the x minus 1 is my other factor, right? And if I set x minus 1 equal to, what are we trying to find?
0.
What would you end up doing at this point, Jose? There you go, so it would be a what? Positive or -1? Positive 1. Also, look right here. That's a +1 right there. Because remember, we're going by 2's.
That's what I asked. What I asked you?
You asked why is it a 1?
Why is it? Why it ain't positive?
No, she said +1.
I thought y'all said it's -1.
-3 and +1. So you good now? Okay.
Oh.
So those are my zeros for m of x. Alright, so let's think about to the left of that first 0. Is m of x going to be positive or negative?
Negative.
Negative?
Oh, positive, no.
Positive?
Yeah, and because it's two
Negative
negatives.
times negative.
What's a negative times a negative?
Positive.
Positive, so we need positives, but is it going to be increasing or decreasing?
Decrease.
It's going to decrease to that what?
Zero.
There we go. Got to that 0. Cool.
Period.
What's after that 0?
The thing in the middle.
It'll be negative.
So it's going to keep decreasing into the
Negative.
negatives, right? What's a positive times a negative?
Negative.
Negative, and then it starts to increase to get back to where? So it's got to increase before that 0. And what happens after that 0? Keeps increasing. All right, so let's check that with the calculator. That's our prediction. And so this is actually something you can do on the calculator as well to check, because I've already set this up. If you click on the blue function f1 of x, okay, it'll bring up these equations here. Scroll down until you find the function that is f1 of x times f2 of x. It's under f4. So click on the line, either line, and it'll open up that equation editor at the top. And scroll down until you find f1 of x times f2 of x. And you see that pink box over there?
Yeah.
Click in it to give it a check mark. So is that what we predicted? Sorry, that's not easy to see, but you should see it on your calculator. Is that what we predicted? Thanks, Ethan.
Yeah.
Look like it? Just a little bit?
Yeah, it looks like it.
Cool. So, let's look back at the lesson. Okay, so we've got m of x there. Oh, I would sketch that in my book. I would use one of the colored pencils. They're under your desk, Jalen. Make sure we're not on our watch being distracting. And I would label this with the colored pencil. Hey, that's m of x, right? I did m of x in purple. Whatever color you use, do that. Do we not have a box underneath our desk? Someone's desk. Hayden, did you look? Oh.
See how different it is.
This is sad as fuck.
Yes, sir.
I'm trying to make sure I'm doing it right.
Say it louder.
I'm trying to make sure I'm graphing it right. I just want you to come look at it.
Remember, focus on those zeros, focus on your slope to give you those linear factors, right? You should also be able to see it on the graph. You don't have to have every point right.
Oh, I see.
You just have to have that general shape right. Okay. Yeah. Huh?
You need a version done it at the end of the year.
Just for this class? Hold on a second.
Yeah.
How do you
We
not
did
want
with
to?
him.
Oh, that's why I look like this. You don't. Okay. Alright. So, let's look at number 2 then. Notice we're going past. Hey, listen. We're going past m of x now. We're going to try to create for number 2 p of x. How are we creating p of x? Look at number 2. They told us p. P of x, right there. We're trying to create the new function p of x. How are we getting that? Not multiplying m of x by p of x. We're creating p of x. It's just a function notation. We're creating the function p. Look at the directions. Start at the very beginning of number 2.
Dilate. I mean, it's by fact.
Alright, so let's pause right there. So what are we starting with?
Dilate.
Well, we're starting with m of x. And what are we doing to m of x?
Multiply.
Dilating it, multiplying it by?
X plus 2.
So let's think about this equation really quickly. How can I rewrite p of x then? We need to get zeros in a second, but think about this fact, right? M of x times x plus 2. How would I write that knowing what m of x is? What do we think? Okay, come on. Would that make sense based on what we know about m of x?
Yeah.
M of x literally is x minus 1 times x plus 3, right? Okay, now we need to graph p of x. Hey guys, I already have m of x graphed, so what do I still need to graph? P of x. Ooh, not, well yes, I'm trying to get to p of x, but what do I still need to graph to get to p of x? Hey guys, I haven't graphed x plus 2 yet, have I? Okay, so what key point should I identify from that p of x right away?
The intercept would be 2.
Which intercept?
Y intercept.
Okay, so y-intercept is 0, 2. Do we know anything else though? Because there's a more important point than that y-intercept. We need that 0, right?
It's -2.
How'd you get -2?
You should put
Equal to
0
0.
first and then.
So remember, we would end up using that 0 product property, x plus 2 equals 0, x equals
Negative student, please pardon the interruption, but when the bell rings for second block,
So,
please name the following students.
x-intercept to -2,
Jake Van Zandt.
y-intercept to +2.
Higer, Jakari Andrews.
And notice it would have what slope, by the way?
Deacon Quincy, Cameron Wilson. Terry
What?
Elliott,
So up 1 to the right.
Alahashi, Alicia Birch, Drayshawn Blackman, Evelyn Smith, Javante Lucius, and Colin Mills.
Alright. So, it's really tight there, but graph your x plus 2 there. Because we need it. We gotta get this third function in here. We got it. We can do this. We can do this. Remember, we had a 0 of negative, x equals -2. And then we had a y-intercept of 2. We also had a slope of 1. So up 1 to the right 1. Up 1 to the right 1. Say again.
Big dot, you mean?
Say that louder.
Big dot.
The black one.
The black points is the one we're looking at. Okay? Don't put that book up. We got 3 minutes left. You must be outside your mind. We got 3 minutes. Outside your mind. Yes. Look. Excuse me, Marshall. Okay. Look up here. Listen. I'm taking m of x and I'm dilating it by what? X plus.
Oh, x plus 2.
So every 0 from m of x is going to be a 0 for p of x, and the 0 for x plus 2. So here's a 0, here's another 0, which is going to get really tight in here. Here's m of x. M of x is what?
M8.
Positive or negative? Positive times x plus 2 is negative. What's a positive times a negative?
Negative.
So all of these are negatives, but they need to increase to 0. We get to that 0, then what's going to happen?
It's gonna increase.
It's going to increase into the,
Parabola. Well, no.
so into the, remember we went from negatives to,
To 0. We trying to get to 0.
we got to 0, then we now need to get to
Positive.
positives. Look, hey, x plus 2 is negative right now. The parabola is also negative. What's a negative times a positive? Or sorry, a negative times a negative is positive, but we need to come back to my 0. Now look at that. What is a positive times a negative? So it's going to go down, and then it's going to go, hey guys, does this look different than what we've been looking at, that black function? It's got more terms. It's got more zeros. You know what we call this function? It's got 3 zeros, so the degree would be third degree or a cubic.
This could be even 3.
Look right here. Hey, this is what we started with. Right there. How many linear factors do we have?
3.
So what's going to be the degree of that? How many zeros is that going to have? 3. Okay. That's what I need us to notice. When it's in factored form, we have to add those zeros up. Oh, hey guys, pause really quickly because this is important. Listen. Pause. Stop. Hey, stop. What we're going to say after that bell rings, I want you to notice this quickly. Look at your linear factors. Every linear factor here is positive or negative.
Negative.
What's 3 negatives give me?
Positive.
Negative.
A negative?
See how that's negative right here? What's a positive times negative times negative? You say negative times negative, right? So notice you just look at your linear factors. If you finish any late homework assignments or I missed one of yours, you need to send me an email. But there's definitely been some good learning today, but what are all of you?
Capable. Yes, more.
Always
Please get out my camera, Marcus. What's
Can you
wrong?
get out my way?
I'm not even. That lame ass Gatorade. Okay. Yes, queen. Yes, it is. It's recording. It's an hour. Yes, y'all. We in Mr. Kenny class.
Yeah, we just learned a lot today.
We just learned a lot today. Don't cut this out, Mr. Kenny. Okay?
Too bad.
That's fine. That is so fine. That's so good. Capable of more.
Always capable of more. Okay. Good morning, Kason. Good morning, Caitlin. Good morning, Jamarcus. You could say it less depressed.
It's still a little early in the morning.
It's 9:30.
That's too early. That's way too early.
Y'all,
Like,
I've been up
you made it
for
sound like-
almost 5 hours at this point.
Yeah, I've been up maybe 2, 3.
Still, you should be awake after 2 hours.